In this video, we want to evaluate the integral of this rational expression here, x squared plus x over x plus 2 times x minus 1 quantity squared. Now, in our earlier video, we did the partial fraction decomposition of this same rational expression. So I'm going to link that video to the description. So I won't go over all the details here, but here's the way we have to start. We want to decompose this we're using partial fraction decomposition. So we have one linear factor, but first we have to check to make sure that we have the appropriate conditions. The degree of the numerator is less than the degree of the denominator. Numerator is degree 2, and because of this product here, the denominator is degree 3. There's no common factors, so it's in lowest terms. So we have one linear factor that's not repeated, so that would be some constant a over x plus 2. And then the next one has a linear factor, but it's repeated. So the process there is one constant b over x minus 1, and then it goes to another constant, and the denominator is x minus 1 to the second. If it was a 3, it would continue. And then we have to find the values of a, b, and c. So in the video, basically we did it this way. The previous video, we multiplied through by the LCD here, which is x plus 2 times x minus 1 quantity squared. On the left side, everything canceled out, except the numerator, of course. Denominator got wiped out. On the first expression on the right, a over x plus 2 canceled. We're multiplying by, again, the LCD, x plus 2 times x minus 1 squared. So the first term left me with a multiplied by x minus 1 quantity squared. X minus 1 canceled, one factor, got b, x plus 2, x minus 1. And then the x minus 1 squared here canceled, leaving me with x plus 2. And that's what we had right there. And then what we did is we treated this as an identity now. So we could pick values, any value for x. So we picked x to be, say, 1. Replace the x by 1. So notice this term goes to 0 here because of the x minus 1. Put a 1 there, that gets me 0. This right here, put a 1 there. 1 minus 1 is 0, so that wipes that out. And for this one here, we get 1 and 2 is 3. So that multiplies to c. And then on the right side, put a 1 where the x is. That's 1 squared is 1 and 1 is 2. So this comes out to 3c is equal to 2. So this tells me then c is equal to 2/3. We get that. And then we pick another number. You can pick any number you want, but to make it easier, you want to pick a value that will cancel out some terms. So we picked 1. Now let's pick negative 2. So notice, because it's x plus 2, if I put a negative 2 here, this goes to 0. Put a negative 2 here, that factor goes to 0, so obviously that wipes out everything. That gets me 0 there. And over here on this side, we put a negative 2 there. That's negative 2 minus 1 is minus 3 squared. That's 9, so I get 9a. And on the left side, negative 2 here. Negative 2 squared is 4, and the minus 2 is 2. So that gives me, dividing by 9 here, this cancels out. A is equal to 2/9. So now we have those constants there. C is equal to 2/3. A is equal to 2/9, and now we just need b. And you can replace another number by, again, in this case, the most convenient one would probably be 0. So replace the x by 0, and we already know c, remember, and a, and solve for b. You'll get that b is equal to 7/9. And then you're in business. Now the other way you could do this type of problem is you could do this right here, especially when you have more complicated expressions. And all I did here is I multiplied through x minus 1 squared, then x plus 2 times x minus 1. This is what we get here. And then we got x plus 2. And then I just collected the factors that multiply x squared. So the coefficients. Collect all the terms with an x squared and factor out the x squared. I get this. All the terms that have x constants, that would be this. And then everything else is just a constant. And then you just equate corresponding values on this side. So here I have coefficient of x squared on the right side is a plus b. On the left side, the coefficient of the x squared is 1. So that means that a plus b has to be 1, like in this equation. And then for the coefficient of the x on the right side, I have minus 2a plus b plus c. Coefficient on the left side, x has a coefficient of 1, that has to be 1. And then for the constants on the right side, I got a minus 2b plus 2c. There's no constant on the right side, so that means you have a 0. So a minus 2b plus 2c equals to 0. And then you solve this system for a, b, and c. You can use elimination and so forth. That's another way you could do it. And of course the b would come out to 7/9, as I said. So with that in mind then, this is going to break up then into the integral. And then we just use what we got here. So we got a was 2/9. So you go put 2/9 here for the a. The denominator was x plus 2. And then it's going to be a plus. And then it was a b over x minus 1. So b was equal to 7/9. So this would be 7/9. And that was over x minus 1. And then it was plus c over x minus 1 squared. So this is x minus 1 squared. And the c was 2/3 with respect to x. And then you have, actually we can break this up into 3 integrals. The integral of this first one, integral of the second one, integral of the third one. And we could actually use a u substitution. So let me just do the first one. Let's look at, let's let u equal to x plus 2. Then du, it would be the derivative, both sides. And we just write derivative of x plus 2, that's 1, times dx, so it'll just be dx. So I could work this out this way then. This would just be the integral of, remember this is dx in all of these. I'm going to break it up into 3 integrals. So dx here, dx here, dx here, and so forth. So this is going to be then 2/9. X plus 2 is the u. Got that. And then this will have a dx right here, but now the dx is the same thing as du. So I got this. And then for the next one, it'd be the same sort of thing. This would be, I'm going to break it up into 3 integrals. So this will be plus the integral of, I'll leave the 7/9 up there. And this will be over u. Again, in this case, u would be x minus 1. I could use u1, but I'm just going to leave it as u. Just realize that it's like 3 different problems. So u is equal to x minus 1 here. Then du would be the derivative of x minus 1, which is 1. And this would be dx. So I could write this as u du. It's like 3 problems in one we're doing here. Now for the next one, I'm going to let u equal to x minus 1. So du is equal to dx, or 1 dx. And then I could replace this and just rewrite this. And okay, this is going to be a plus 3rd integral. So I'll break it up into 3 problems. Leave the 2/3 up there. That's going to be over. And then again, u in this, for this problem will be x minus 1. So replace that by u squared there. That's u, and then it's squared. And then this is dx, again, applies to this one also. This would be du. So now we know that if you have the integral du over u, have the integral of du over u, and if you have a constant here, you can always bring it outside the integral there. This is always going to be natural log of absolute u, absolute value of u, plus a constant of integration. So for this one here then, got the integral then, and there it is. Remember the 2/9 I could bring it out, so I'm just going to bring it out here. This will be 2/9. And if you look at what's inside the integrand, that's just going to be du over u. Well, that's the formula over here. So that's just going to be the absolute value, or the natural log rather, of the absolute value of u, where in this first problem, the u is x plus 2. So I just put it. Always got to go back to the original variable. This is x plus 2. And then you have your constant of integration. But that'll come at the end. And then for this one, same sort of thing here. 7/9, I can bring that out here. And then all I'm going to have then is integral of du over u. Well, that's again using that formula, the natural log of absolute u. Or in this case, u is x minus 1. Okay, so I'm doing it. It's 3 different problems, and we get one answer for the problem. We get that. Now for this one here, let me do it on the side. Okay, so for this one, I'm going to write it this way. This will be integral, and then the u squared, I take it to the top. That'll be u to the negative 2 du. And then I got a coefficient. I'm bringing it outside 2/3. So just basic integration here. I add 1 to the negative 2, gives me a negative 1. And then I divide the coefficient 2/3 by negative 1. This gives me a negative 2/3. So the final answer that I put here then will be minus 2/3. And this is your answer, but it's in terms of u, so we want it in terms of x, the original. So all we have to do here then is u is equal to x minus 1. I put x minus 1 here, negative 1 there, and then it's your constant of integration. That's your solution. And you should be able to take the derivative of this expression and get this integrand right in here. That's the way you would check it. Sometimes doing the check takes you longer than working out the problem. But that's the solution using involving partial fractions. Have to find the partial fraction decomposition. Again, I'll link the video to that particular problem in the description, just in case you haven't done much with partial fractions. Thanks for watching. We'll see you next time.